Hi everyone, in this video on arithmetic sequences, we're going to work through this exam question in which we need to find this sequence's unknown first term. Now if you're up for it, go ahead and press pause and try working through this before watching the rest. Either way though, let's get started. Now I'll start by moving this to the side, like so, and by writing SOL for solution. Okay, we're told an arithmetic sequence has a common difference of 4. We're then told if the fourth term is 18, find the first term. Okay, well the first thing I'd like to draw your attention towards here is the fact that we're clearly told that this sequence is arithmetic. And this is important because it tells us two things. Indeed, it tells us that in this sequence, to get from one term to the next, we're always adding the same amount. That amount being the common difference of 4. And it also tells us that the nth term of this sequence must be given to us by the formula for the nth term of an arithmetic sequence, which is the nth term u sub n equals to the first term u sub 1 plus n minus 1 written in parentheses times the common difference d. And I'll go ahead and box that. Remember, that's the formula for the nth term of an arithmetic sequence, which is given in quite a few exams. Indeed, if you're an IB mathematics student, for example, this formula will be in your formula booklet. But whether or not you're given this formula, you should definitely know it. I carry on and I make note of some important information given in the question. Remember, we were told that the common difference of this sequence is equal to 4. And so I can already make a little bullet point here, and I'll write d, that's the common difference, equals to 4. We were also told that the fourth term is 18, and so I'll write that as well. We're told that the fourth term, u sub 4, equals to 18. And of course, we're asked or told to find the first term. The first term is typically written u sub 1, and so I can write u sub 1 equals to question mark. That's what we need to find. Okay, well to solve this problem, we can follow one of two approaches really. And so to separate them, I'll make a line in the middle of the screen, like so. And I'll start to the right-hand side of the screen, underneath the formula for the nth term. The reason being, the first approach involves using this formula. And here's the whole idea. We already know that provided we know the value of the first term and the common difference, the formula for the nth term, or general term, allows us to calculate the value of any term directly. Indeed, if I copy this formula very quickly here, the general term, or u sub n, which equals to the first term plus n minus 1 in parentheses times d, we know that if we know the value of the first term and of the common difference, then if we need to calculate, say, the 20th term, all we'd have to do is replace the n we see here by 20, calculate, and the number we'd get on the right-hand side here would equal to the 20th term. But to solve this type of problem, we're going to use the fact that that's not all that this formula can be used for. Indeed, let me quickly copy that again. So the formula for the nth term, which equals to the first term plus n minus 1 in parentheses times d, alongside what we've just said, this formula can also be used to find an unknown common difference, an unknown value of n, and an unknown first term. And finding an unknown first term is clearly what's of interest to us in this problem. And the idea is, provided we know the value of the common difference, and provided we're given the value of any term in this sequence, and so remember, in this case we were given the value of the fourth term, which is 18, then since we know the value of a term, we'll know what the value of the left-hand side is here, as well as what the value of n is. Indeed, since we know that the fourth term is 18, we know that when n is equal to 4, the left-hand side here has to equal to 18. And consequently, looking at this formula here, alongside the information we have in this question, we see that everything that I've just underlined in green here is in fact known. In other words, the only unknown we have inside this formula is the first term that we need to find. And so this first method involves using this formula, replacing the values that we know, and solving for the unknown we need to find. More generally, it's important to keep in mind that if we know or we're given 3 of the 4 things I'm circling right now, then we'll always be able to find the one that wasn't circled. And so in this problem, just to be clear, we know we can use the formula for the nth term to solve this problem, since we have 3 of these 4 things. Indeed, we know the 4th term is 18, so this would be equal to 18. And since we're dealing with the 4th term, this would be equal to 4. And last but not least, we're given the common difference, so we know this right here. We're therefore left with this one that hasn't been circled, which is the first term we need to find. All that being said, back to it. Since we know that this sequence's common difference is 4, which remember I wrote here, we can go ahead and copy this formula for the nth term, but replace the common difference by 4. In other words, although we don't know what the first term is yet, we already know that the formula for the nth term of this sequence has to look something like this. U sub n equals to the first term, u sub 1, plus, in parentheses, n minus 1, times the common difference, which is 4. And I suppose I could write above here a little bullet point. That's using the information d equals to 4. There we go. Next, we turn to the second bit of information that was given in the question. That was that the 4th term is equal to 18. And so I'll do a second bullet point here. I'll use the fact that the 4th term, u sub 4, is equal to 18. Indeed, using this bit of information alongside the formula for the nth term we just wrote here, we can go ahead and state that when n equals to 4 since it's the 4th term, the left-hand side of this has to equal to 18. In other words, copying this formula but replacing the left-hand side by 18 and the n we have here by 4, we quickly obtain 18 equals to the first term u sub 1 plus, in parentheses, 4 minus 1 times the common difference, 4. Now, since 4 minus 1 is equal to 3, this quickly turns into 18 equals to the first term u sub 1 plus 4 minus 1, which is 3, times 4. I carry on. We have 3 in parentheses times 4, and I should say that at this stage, this pair of parentheses serves no purpose whatsoever, so we treat this as 3 times 4. And this turns into 18 equals to the first term, u sub 1, plus 3 times 4, which is 12. And here we can clearly see that we've ended up with an equation with one single unknown, which is the first term we're trying to find. And so to find it, all we have to do is solve this equation. And for that, we're going to get rid of this 12 that's being added to the right-hand side, which we do by subtracting 12 from both sides of this equation. And so we get 18 minus 12 on the left-hand side, which of course is 6, and that's equal to the first term u sub 1 plus 12 minus 12. And since 12 minus 12 is 0, we're just left with the first term u sub 1. And so we can state that 6 is equal to the first term, or even better, the first term is equal to 6. And we're done. We've just found this sequence's first term. And so in this method, we clearly made use of the formula for the nth term of an arithmetic sequence. But now let me show you a second method for solving this problem, which many of my students prefer as it's a little bit faster. And here's the whole idea. Although we don't know what the terms of this sequence are, we do know that it's an arithmetic sequence with a common difference of 4. Consequently, we know that as we go from left to right in this arithmetic sequence, so as we go from u1 to u2 to u3 to u4, which is known, remember that was 18. As we go from one of these terms to the next, we're always adding the same amount, which is the common difference, which is equal to 4. So from u2 to u3, we're adding 4, from u3 to u4, we're adding 4, and so on and so forth. And now using this fact, a quick way to solve this problem is to ask ourselves how many times have we added 4 to get from the first term, which is what we're trying to find, to the 4th term, which is the term we were given. And looking at what we have here, it's quite clear that to get from the first term to the 4th term, we've added the common difference 4, 1, 2, 3 times. In fact, I could annotate that underneath there. To get from the first term to the 4th term, we've added 3 times the common difference d, which remember is 4. And now using all of this, that allows us to quickly state that the 4th term, u sub 4, is equal to the first term plus 3 times the common difference d. And so I could write that the 4th term, u sub 4, is equal to the first term plus 3 times the common difference d. And all we have to do now is replace this u sub 4 by its value, 18, and this d by its value, which was 4. So this becomes 18 equals to the first term, u sub 1, plus 3 times d, which becomes 3 times 4. And since 3 times 4 is 12, this becomes 18 equals to u sub 1, the first term, plus 12. Here we clearly see that we end up with the same equation as the one we had earlier on, and we can solve this equation for the first term, u sub 1. For which all we need to do is get rid of this 12 that's being added to the right-hand side, which we do by subtracting 12 from the right-hand side. And of course we do the same on the left-hand side. And so we have 18 minus 12, which is 6, and I'll quickly write that, that's 6, which equals to the first term u1 plus 12 minus 12. And since 12 minus 12 is 0, that leaves us with 6 equals to u1, or u sub 1. Finally, the first term, u sub 1, is equal to 6. And we're done. Now one could try to argue that this method is only feasible if the term we're trying to find can easily be represented on an illustration like this one. In other words, you may be thinking that this illustration was only convenient because the fourth term wasn't too far away from the first term. So if ever the term we had been given hadn't been the fourth term, but instead had been the 50th, 100th, or 200th term, then writing all the terms out the way we did here wouldn't be possible. But the good news is we didn't actually need this illustration at all. Indeed, instead of drawing all of this, all we really needed to figure out is how many times the common difference needed to be added to the first term to get to the fourth term. And luckily for us, we could have figured out that the number of common differences we needed to add was 3, simply by looking at the 4 we have here, 4 for the fourth term, and the 1 we have here, which indicates the first term. Indeed, we could have figured out how many times we had to add the common difference here simply by considering 4 minus 1, which, as you know, is equal to 3. And it's 4 minus 1 here because we're looking for the fourth term, and we're starting at the first term. So if ever you're faced with a question like this one, in which you need to find the first term and you're given, say, the 99th term, then you could quickly obtain an equation like this one and write that the 99th term is equal to the first term plus 98d. In other words, 98 times d, where this 98 is nothing more than 99 minus 1. Indeed, 98 equals to 99 minus 1. And there we have it. As such, this method is the same thing as using this formula here, but it allows us to do so without having to think of using the formula, and lets us think of how many times the common difference has been added instead. That being said though, it doesn't matter which of these two methods you choose, whichever one you feel most comfortable with will lead to the same result in the end. All that being said and done though, that's it for this tutorial.